The topic of my presentation is from making to manufacturing, the missing link. That missing link, in fact, is the thing I was talking about before. The reason it is not easy to use certain products like Raspberry Pi, like Arduino, to go into mass production. By the way, my name is Gianfranco Cocmune. I'm the Senior Sales Engineer for SECO and also for UDO. A little bit about what we're going to talk today. This is usually, I apologize beforehand, this is usually a presentation that takes me about 45 minutes to run through. It's pretty long. It has a lot of information. I'm going to have to do it in 20 minutes, so I'll be flying through the slides. This is a little bit the topics we're going to be talking about today. And let's start a little bit by defining what makers are. Of course, everything that applies to makers also applies to IoT innovation labs or startups because the concepts are going to be the same. So the best definition is makers, they spend their time in makerspaces because they love to do what they're doing. Okay? They don't want to buy Christmas gifts, they want to make Christmas gifts. On the other hand, you have a completely different world, which is that of manufacturing, where you make wares by hand or by machinery systemically. Okay, so there's a system behind it that makers and typically startups don't follow. Arduino, as I said, is arguably the biggest reason for the explosion of the maker community. It enabled an endless world of possibilities. So it enabled people who did not even have experience to go and create a proof of concept. Of course, it enabled the possibilities to go into mass production. It didn't realize those possibilities. So there's a difference between having the ability to do it and actually doing it. As the inventor of Arduino said, people could use Arduino to make circuits, make prototypes. People were beginning to create companies out of Arduino. Unfortunately, 95% of those companies failed. Because of the fact there's that missing link, there's a missing step that I was talking about. A little bit about manufacturing. It's an extremely lucrative field. In the US alone, the GDP for manufacturing is $2.09 trillion in 2014. That alone would be the 5th biggest economy in the world. Okay, 12% of our GDP comes from that. 75% of all research and development comes from manufacturing. The thing is, as Mark Hatch from the CEO of Tech Shop says, the makers right now are creating products that are worth billions, saving lives and changing the world. This is also proven by the first ever Maker Fair at the White House in 2014, where even the president recognized the importance of the maker movement. He promised new support for startups that want to file for a patent, and that they are part of a revolution that's taking place in American manufacturing. It's a revolution that will change the way products are created. They're not going to be created in labs anymore. We're not going to have Bell Labs like in the 60s. We're going to have a person in his basement or a person in his college creating a product that might gross $10, $12 million in a year. This is also proven by one very important aspect today, crowdfunding. Kickstarter is probably the biggest and most important example. These are numbers from Kickstarter. $480 million in 2013, $529 in 2014, a 10% increase. Considering GDP is typically about 2% increase per year, it's fivefold that. In all of that graph, as you can see, technology leads. It's about 24% of the totals at $125 million. Now, more specifically, what we will focus on as IoT and as makers is what's called embedded technology. So embedded system is a computer system that is dedicated within a bigger system made of mechanical components, made of many other things. So an embedded system is not a laptop that is specific and does only that function. It's a part of something that has a broader range, a broader purpose. One important thing is embedded systems today are pervasive. There's nothing technological today that doesn't have some sort of embedded system. Appliances, cars, microwaves, they all have embedded systems. As I was saying, even though the concepts are innovative, they're great ideas, most of them are going to fail and disappear. There's one big factor in this. When makers and startups decide to manufacture, they usually have an excellent business plan and a great marketing pitch. Often, they refer to consultants for these two fields. And it's wonderful because when they go to pitch their product, it's exactly what they need. The only thing is, they're missing one important thing, and that's the manufacturing strategy. How do I manufacture that product? What are the pitfalls? What are the problems that I'm going to face? What are especially the requirements that I'm going to need to talk about? So, if you want to create a manufacturing strategy, and we are a manufacturer, we see this every single day, both from our industrial customers, but also from startups and companies that want to get into the market, you need to understand the market. There's a huge difference if you're talking about various markets: consumer, industrial, medical, automotive, transportation. All these markets have different requirements, different pitfalls, different problems. Not only, once you decide, you also need to learn about the manufacturing process aspects and requirements. So you need to know that manufacturing flow chart, but not only from a business point of view, which is in your business plan, but from a manufacturing point of view. And then you come to the third part, which is choosing the most effective path. I'm going to anticipate something. How many of you have ever heard of buy versus build? It's the most simplistic and I think overestimated term that you will hear, because it's not that simple. First, it's not only buy versus build, there's a third option which we will see. And both of them have their pros and cons, but both of them can be hard to get into. Now, it's almost impossible to list all the processes of manufacturing, even more so embedded technology. So I'm going to try to give a superficial idea of what we're talking about. I'm just scratching the surface here, literally scratching it. But just what I'm going to present will have people scratching their heads on manufacturing. Some terms that people encounter. These are the first terms you encounter when you're manufacturing: EAU, MOQ, and RE. Estimated annual units. That's how many units you're telling the manufacturer that you will have him manufacture for you a year. These AAUs tend to be numbers highly exaggerated. So what do some manufacturers do? They say, okay, I have a minimum order quantity. That means you have to promise me and order at least X amount per year. The third one is the NRE, the non-recursive engineering fee. This is a fee that manufacturers or design firms usually ask beforehand in order to work with you on your custom design. This is to make sure that they don't put research and development time into something and you pull back. A lot of companies charge even a few thousand to $20,000, $30,000, $40,000 of NRE. Some companies like us return that NRE in time as if it were a deposit. Most companies keep it as a service fee. These three things alone are commitments that a startup may not be able to fulfill, or it's a promise they may not be able to keep. These terms that I just used are nothing, though, compared to one important aspect: PLM, Product Lifecycle Management. This is probably the most important part of manufacturing that nobody knows about. Once they start learning about it, it's too late, and they fail. PLM is defined as the process or system, and we go back to systematic, used to manage the data and design process associated with the life of a product, from its conception to its retirement and disposal. How long is your product going to be on the market? 8 years? Well, guess what? You have a child for 8 years. That's literally what it is. You're taking care of this child. You're finding all the information. If something changes, you need to then adapt what you're doing to make sure that that change does not affect your product and ultimately your customers. PLM covers the entire production chain, and this is what is going to ensure that you make a product that is successful, or if you fail right off the bat. These are five of the most important processes, but the process could be up to 60 different requirements. These are the 5, let's say, most backbreaking: procurement, quality control, LTS, ECN, PCN, EOL. These typically require me to talk a lot about them and also ask questions. I won't have time. However, I want to anticipate. I have a booth, if anyone has follow-up questions, 1914, the SECO booth. Tomorrow there's going to be a presentation in Hall C, I think, Do Makers Make Products? And that's a 45-minute session that there will be a panel, including myself, and we'll also be talking about these various aspects, or at least I will. I'm the only hardware manufacturer there, so. Okay, the first one, procurement. This is where people really have no idea what's going on. Procurement is these steps, but as you can see, and that's the definition from a website that is specialized in PLM management, it often involves. Doesn't necessarily always involve those steps, doesn't necessarily involve only those steps. But of these steps, I think the most important one that is the one that destroys the old buy versus build, if you want to go build, it's price negotiation. Price negotiation, because the only way to get a good price on what you're building is if you promise volume, because volume creates the leverage for you to go to a supplier and say, I need this price. Quick example. You're working with Raspberry Pi. Raspberry Pi orders 100,000 processors a year. You need 100. Guess what? You're going to find out the processor costs more than what you paid for the board at Micro Center or Best Buy. Because they're buying that processor $2 each because they're getting 100,000. You're asking for 50. The processor costs 25 now. The board itself costs 30. And that's just the processor. You have thousands of components to worry about. Each is going to cost 10 times what a board manufacturer would buy. You're bankrupt because you made a business plan on a $25 board that now costs you to manufacture $300. How are you going to go? Where are you going to go from there? How are you going to present it to a company? LTS, long-term support. And this is also something that nobody ever mentions. It's the guarantee that the product will be available for a defined amount of time. As I said, you want a product, you're calculating an ROI for 5 years. You're working on a product that doesn't have LTS. 6 months from now, that product will be discontinued. You promised it for 5 years. What are you going to do? You either discontinue and go bankrupt because you made promises, or you buy 5 years worth of stock, invest in that capital, and have it in some warehouse somewhere and take it as you need it. That's a huge amount of capital. Okay? The requirements of long-term support is managing any parts or components that become obsolete or discontinued. Stock management, capital to be able to buy these parts. Or you declare premature obsolescence, and that destroys your reliability, your reputation. And the lifetime of the product has to be at least the lifetime of the most important component on the board. In the case of embedded boards, it's the processor. The processor is the most important component. Now, if you're talking about a product like Raspberry Pi Arduino, where they say, what, lifetime? I don't know. If I don't want that product in a month, I'm going to kill it. You can't force that company to give you a lifetime. They decide it. You need to know beforehand that that's a risk. You need to know that in a month or 6 months, that product may not be available. You need to run and find a suitable substitution. You don't find it, you can't sell that product. You can't pitch the product. You go bankrupt. Quality control. This is the procedures or set of procedures that makes sure that your product is as promised. Okay, whether you're promising it as an off-the-shelf or to a customer. It requires weeks of work to validate, to make sure a product, a prototype is working, weeks of work. Tons of experience, which typically startups and makers don't have. Technical skills and knowledge, which by definition makers don't have. It's an extremely delicate task, and often companies want some sort of certification or proof. The most famous are CE, which is becoming worldwide, or UL, right? In the US, we see UL a lot of places. And I'm not talking about the more highly specialized ISOs, FCCs, and all these other things, not mentioning FDA and FAA, which are killers. ECN, PCN, Engineering Change Notice, Production Change Notice. These are processes that deal with the obsolescence of parts. And by parts, I mean on an embedded board components. Not the entire board, but one stupid little component. It can even be a 30-cent microcontroller that you now need to run and find a substitute for. It could be as simple as finding a compatible drop-in. So the manufacturer himself says, this is end of life, but this is compatible, just put it in. However, you still need to revalidate that board because you're putting it in, but you don't know if it will work. Weeks of experience, weeks of work, quality control, validation on a board that you were sure for 5 years would be as is. What if it's not compatible? What if the manufacturer does not have a compatible one? You need to go and do all your research of all the manufacturers that have something of that sort, eventually probably redesign the board, which is called a board revision or a board respin, revalidate from scratch, make sure it works, notify your customer of the changes you made. Once the component has been replaced, you send out an ECN or a PCN to all your customers that have leveraged your board. That right there is what we do typically every single week. We have a department that does that because that is a job in itself. Seeing if you have the replacement all the way down to notifying the customer. If you don't do that and you promise the customer 5 years worth of product and he doesn't know that it's going end of life and it does before you tell him, you're bankrupt. He'll sue you, especially if you have agreements in place. EOL. No ECN, no PCN because you didn't find a compatible replacement. All of a sudden, your product is end of life. You can't fix that vital component. You have a few options. If it's going to be discontinued or obsolete, there is no standard process. Okay? Usually, it's mandatory though for industrial applications, not as much for consumer. Consumer applications, I don't know, you have a washing machine, you bought it 2 years ago. Your grandmother wants it, your mother-in-law wants it, you go to the store to buy it, guess what, it's not there anymore, it's discontinued. Who cares? They didn't tell you yours is discontinued, you don't care. Industrial applications don't work like that because you promised that the board will be available. There's usually a process behind it, though, that is standard. So there's three things. One, when the product won't be available anymore. So the date when it's going to stop its availability. A last time buy, which is telling your customer when is the last time they can purchase that board, and last time ship, which is usually anywhere between 6 months and a year after last time buy. Now, in this process itself, there's two important factors. One is telling him it's going to be unavailable. How many pieces do you need for the lifetime of your product? You need to buy those pieces for him. If he says 100,000 in 5 years, you buy 100,000, 110,000 in 5 years. And you have to stock them. So imagine a startup that has 5 or 6 components on a board, EOL. He's stocking 500,000-600,000 components somewhere in some warehouse for 5 years. What is the overhead on that? You didn't calculate that in your business plan, did you? Okay? Because you couldn't. You don't know what's going to go and when it's going to go EOL. These are practically the basic steps that you need to look into, as I said, scratching the surface, into a manufacturing strategy. So how do you develop a manufacturing strategy? How do you get your proof of concept into stores, onto shelves, into a car if you created an automotive? The first and foremost thing is you need to ask yourself two questions. Which market is going to be your target market? Second one, for how long? Consumer markets tend to be 1 to 3 years. They're short term. They don't have product life PLMs. They don't have EOLs. You don't really care. But if you touch any of the other ones, and those are just some of them, industrial, 5 to 10 years. Automotive, 10 years. Transportation, trains, planes, 30 plus years. We have a customer who designed for train systems in the late 70s. Those trains are still being used today because you know how they get declassed, they get used for other purposes. 30 plus years for a product that you promised someone. The timing of these questions, of those two questions, are extremely crucial. You don't want to start developing on a product, spend hours of time, effort, capital, buying equipment, buying everything, and then all of a sudden you go to pitch it and you find out can't be done. Can't be done. The company is not going to manufacture industrial for you. The maker of the board himself won't do it. The board might be obsolete. The board is going obsolete. You have a fully functioning proof of concept, and you find out not only is it difficult, so it can't be done, but if it can be done, it's extremely expensive. It costs more than what you paid for your proof of concept, maybe 3 times more. That means anything you calculated in your business plan goes out the window. Convincing VCs or companies becomes a useless effort at that point. They probably won't even let you in the door, and if they do, the first question is, okay, when is my ROI? Okay, 2 years, good. This board is going obsolete in 6 months. How can we fix that? Okay, that's one of the biggest pitfalls right there, is they go and pitch a product that is already too late for any type of ROI, let alone profit. Because ROI is a word we throw out there, but companies don't care of ROI. Who here would invest $10,000 to get back $10,000 in 3 years? We're talking about profit, not ROIs. I don't care about ROIs. When I'm pitching something, I don't care about ROIs. I don't want to break even. I want to make a profit, which means doubling the ROI at least. That's why I wrote R before D. It's not a mistake. It's not research and development in your cases. It is in ours because we have the means and we have the contacts and we have the suppliers to be able to manage research and development at the same time. For makers, startups, for IoT, the research has to be done before you even touch a product. Make sure you're working with the right product. So here we go. You decided your market, you decided for how long. Now how do you go into manufacturing the product? Build versus buy. I don't believe in build versus buy. I build in build versus buy versus hire. Because there's 3 options. You can self-manufacture. That means you have someone behind you who's willing to pay for all the instruments, the machinery, for you to go into technological manufacturing. The pick-and-place machine, the X-ray machine, the prototyping machine. Millions of dollars, but you have somebody that helps you. The second one, use a contract manufacturer. That means you have your design, you have everything, you go to someone, you say, I want you to manufacture this for me, I'll pay you whatever it is, I'll sell the product. That's the hire part. And the third one is the buy, off-the-shelf embedded manufacturers. Some examples of this are Arduino, Raspberry Pi, Udo, which is the product that we provide. Really quick through these. These are the issues when you go into building yourself, okay? There's some positive things. You can buy some low-cost machines today. You have total control. However, huge initial capital. You do avoid MOQs and NREs. However, you have no economy of scale. You can't leverage pricing. Component suppliers have extremely high MOQs. We're talking about 50 to 100,000 pieces a year if you want to make your own board. Extremely long time to market. TTM, you'll find that everywhere when we're talking about technology. That's one of the most important things. That goes back to ROI and profit. If it takes me 2 years to put the board on the market, I've already lost money. If it takes me 2 months, I'm happy. The learning curve and the PLM are killers. It'll take a startup just to learn about the requirements and to learn how to manage PLM years, if they're ever capable of doing it. Because those are what we're paid for. That's what we go to school and train and get degrees for, is to be able to manage the PLM and the production cycle. Contract manufacturers, they allow economies of scale. You save time, you save cost. They might be skilled in your field, 2 minutes, for mass production. They're highly focused on the segment. However, you don't have control. You risk intellectual property. You don't have flexibility. High MOQs, typically NREs, and they might not offer PLM management, if not at a fee. The third one, off the shelf. For example, Udo, Raspberry Pi, Arduino, WAN board. These are some of the boards. They're already available. They're already mass-produced. You typically don't need any capital to be able to go into these boards. The problem with most of these boards is they don't allow the transition from their consumer products to their industrial products. Okay, I'm not going to go through all of these because unfortunately I only have a couple of minutes left. However, a problem also with these off-the-shelf boards is no PLM guarantee. Raspberry Pi won't guarantee that that board will be available for 5 years. Okay, there are some, for example, Raspberry Pi itself, they created a program where you can go into industrial manufacturing. However, as you can see, they want 3,000 to 5,000 boards a year promised. If your project is 100 boards, they won't even look at you. These are some of the questions, of course, that even if the manufacturer does come up with an industrial plan, you have to ask yourself. Those on the bottom are the most important. Who's going to handle procurement? How are PCN and ECN managed? So these are extremely important aspects. 2 words, support and flexibility. Whoever you pick has to give you the support you need for that product, has to give you the flexibility of being able to adapt to your needs and requirements. They have to have a product that can be scalable, so it can be used in a few years, but also it has to be a product that can be broken off from the chain of your system and be replaced with something else. So I'm just going to conclude with this. I'm not going to go into the products that we have, but practically Raspberry Pi with their program is starting to do what we've been doing with our products in the past 3 years. The most important products that we've been using for the makers are, I'll go straight into the products. Udo. This is an open source maker board that came out in 2013. It enabled many makers to create proofs of concept. What we did was when we were starting to get requests for industrial manufacturers, Udo had these 3 problems. No long-term support, it wasn't rugged for industrial applications, and it wasn't cost-effective for mass production because of the components on the board. What we did was we came out with a new board, the SECO SPCA 62. This is the industrial version of Udo. It's exactly putting into operation what I was saying, enabling the transition from a maker board to an industrially proven board with PLM management, long-term support, and all the requirements for industrial applications. If you want to see these products, I have them, as I said, at the stand 1914. And if you have any follow-up questions, just come ask me or come to the presentation tomorrow at 11:45, Hall C, I think, where we'll be talking about this again, and I'll get back into hopefully a little bit more detail about this. Thank you very much for your attention. Sorry about the rush, and I hope it was interesting for you. Thank you.